So I'm sure that many of you have been, constantly thinking to yourself, what is a really great chemistry pickup line? Well, I've got one for you. Hey, baby, I've got my eye on you. Get it? Eye on. Yeah, I think it's funny. Anyways, so let's get started. The title of the notes is Equilibrium. And Keq, should probably make a K, Keq calculations. And just as a reminder, Keq equals the concentration of the products raised to their coefficient all over the concentration of the reactants raised to their coefficient. So today what we're going to be doing is making our equation first and then plugging stuff in second. So let's go ahead and start with example 1. And that's going to say calculate the Keq for the following reaction. And that reaction is 3H2 gas plus N2 gas, equilibrium arrow, gives us 2NH3 gas. If the equilibrium concentrations are 3.7 molar NH3, 2.5 molar N2, and 0.89 molar H2. So the first thing we're going to do is write our Keq expression. Keq equals products. So the concentration of NH3 raised to the 2 all over the concentration of H2 raised to the 3 times the concentration of N2. I could put a 1 there, or I could choose not to put a 1 there. Doesn't really matter. So that's the first step. So we found our equation. And they want us to calculate the Keq. So Keq equals this. And I have all of my numbers that I can plug in. Remembering that the brackets, that just means concentration. And usually concentration is measured in molarity, which is capital M. And notice they gave us the molarities, or the concentration, of all 3 of our substances. So all I have to do at this point is plug and chug. So let's go ahead and do that. So the concentration of NH3 is 3.7. So it's going to be 3.7 squared all over the concentration of H2 is 0.89. And that's going to be raised to the 3rd power times the concentration of N2, which is 2.5. So I take this step by step just so that way I don't make any mistakes. So the first thing I'm going to do is do the 3.7 squared, and that gives me 13.69 all over. And then I'm going to do the 0.89 to the cubed, and that gives me 0.70497. And then just times the 2.5. So when you're typing this into your calculator, you're going to type that guy in, you're going to hit divided by this guy, and you're going to hit divided by again this guy. So make sure you type it in correctly. If you want to type it in all of your calculator just with the exponents, you can. Okay, I just want to make sure that you guys are following the steps. So you type that into your calculator and it spits out 7.7677. And we're going to do sig figs, so I just look back at the problem. This number has no, it doesn't. This number has 2 sig figs. This number has 2 sig figs. And this number also has 2 sig figs. So the lower number is 2 sig figs. 6 bumps the 7 up. So the KEQ equals 7.8. There are no units with this. None whatsoever. Okay, so it's just the KEQ is this constant for this reaction with these concentrations. We're going to do a couple more examples. So, example 2. Is going to say, write the equilibrium expression for SO2 gas plus O2 gas, equilibrium arrow. Notice we're going to have to balance it. I'm leaving these lines for a reason. SO3 gas. So I'm going to balance this guy. It looks like I've got S's and I've got O's. I've got 1 S and 4 O's. And I've got 1 S and I've got 3 O's. So in this case, let's see. I can make 12, or I think if I made 6 of these on each side, that would also work. So I'm going to go ahead and I'm going to put a 2 in front of the SO2. That gives me 2 S's, and 2 times 2 is 4, plus 2 is 6. And then I'm going to fix S on this side, so if I put a 2 in front of SO3, 2 there, that gives me 2 S's and 6 oxygens. So now we're balanced. So write the equilibrium expression for this guy. And then also we're going to say, and calculate the KEQ if the equilibrium concentrations of the substances are ... 1.5 moles over liter SO2, comma 1.6 moles over liter O2, comma 2.5 moles over liter SO3. So the first thing I'm going to do is I am going to write my KEQ expression. So KEQ equals products, which is SO3, so the concentration of SO3 raised to the 2, all over the concentration of SO2 raised to the 2, times the concentration of O2. Okay, they're all gases, so I can include all 3 of them. So next up, notice they gave us moles over liters. Moles over liters, guys, that's just molarity, which is concentration, which is what these brackets mean. Okay, so now from this part, I'm just going to plug and chug. So SO3 is 2.5 squared all over SO2 is 1.5 squared, and O2 is just 1.6. So if you're taking it step by step, this is what it would look like. So it'd be 6.25 all over, that's 2.5 squared, 6.25, all over 2.25, that's 1.5 squared, times 1.6. When you type this into your calculator, make sure you hit divided by this guy, and you hit divided by again for the 1.6. and your calculator is going to spit out 1.736111. And look back at the problem. Looks like all three of these are 2 sig figs, so the answer is going to have 2 sig figs. So the KEQ just equals 1.7. It doesn't round up. Okay, one last problem. We're going to increase the difficulty a little bit. And this is going to be example 3. And we're going to say find the equilibrium concentration of H2 if the concentration of S2 equals 0.7 molar, comma, the concentration of H2S equals 2.7 moles over liter, and KEQ equals 1.87. And our formula is going to be 2H2S gas, equilibrium arrow, 2H2 gas plus S2 gas. Let's see what our time is. Time. Okay. So the first thing I'm going to do is write my KEQ expression. KEQ equals products, so H2 squared S2 raised to the 1 all over the concentration of H2S raised to the 2. This problem's a little bit different. They want us to figure out the equilibrium concentration of hydrogen, and they give us the concentration of S2, they give us the concentration of H2S, and they give us the KEQ. So I'm going to go ahead and plug and chug first. The KEQ is 1.87, so 1.87 equals, and they want us to find the concentration of H2, which is H2 squared. I'm just going to say that that is X squared, times the concentration of S2, which we know is 0.7, all over the concentration of H2S squared, and H2S is 2.7. So 2.7 squared. So the first thing I'm going to do is I am going to actually cross multiply. There's technically a number 1 there. And I'm going to cross multiply these two. And that's going to give me 1.87 times 2.7 squared equals, then I'm going to cross multiply the other two, and that's going to give me X squared times 0.7. Okay, so we're solving for X squared, solving for X, okay, which is just H2. So that means I'm going to divide each side by 0.7. And when you type all of this into your calculator, it spits out 19.4747 equals X squared. So we got rid of the 0.7. So now you need to solve for X squared. We just want X, not X squared. So what we need to do is take the square root of each side, and that's going to give me 4.413 equals X. Okay, but X was really just the concentration of H2. So 4.413 equals the concentration of H2. And I need to give it sig figs. 1 sig fig, 2 sig figs, 3 sig figs. So the answer is going to have 1 sig fig. So the concentration of H2 equals 4, and concentration is in molarity. So you can say big M, you can say moles over liter, or you could say molar. Okay, so make sure you also finish 18.3 if you didn't already. Have a great evening, guys.